Bismillah ar-Rahman ar-Rahim. Hello everybody. This is a video about integral. The aim of this is to give that we can find the undefined integral or defined integral by many ways. The first way, since here we are dealing with cosine, sine, tangent, trigonometric function, there is no x, there is no square root. So the universal change of variable, which is given by tangent x over 2 equal t, this implies that, as we saw this in the last video, 1 plus t square dt, sine x is equal to 2t over 1 plus t square, and cosine x is equal to 1 minus t square over 1 plus t square. So we replace in this integral, we get cosine 1 minus t square over 1 plus t square, sine 2t over 1 plus t square, dx 2 over 1 plus t square dt, 1 minus 2t over 1 plus t square. So this is equal to 4. So here 2 and 2, this means 4. The integral here, we get 1 plus t square minus 2t. We will cancel this, cancel 1 plus t square with 1 minus plus t square, and we get 1 minus t square t over t square plus 1 minus 2t. This will be cancelled, and 1 plus t square dt. This is equal to minus 4, the integral t square minus 1 over t square plus 1 minus 2t. This is t minus 1, so t minus 1 square times 1 plus t square dt, which is equal to t minus 1 times t plus 1. We have here t, so here we have t times t over t minus 1 square times 1 plus t square dt, which is equal to the integral t plus 1 t over t minus 1 t square plus 1 square dt. And the decomposition method to irreducible fraction allows us the method. We can do it later. So this is equal to a over t minus 1 plus b1 t plus b2 over 1 plus t square plus c1 t plus c2 over 1 plus t square dt. Then, by identification with this integral, one plus t square dt, by identification of the polynomial here from order 3 or 4 with this polynomial. So the coefficient of the order 3 and 4 are equal to 0. So here we have to identify, and by identification of a couple equation, 6, I think, equation. 1, 2, 3, 4, 5. 5 equation. We will get the values of A, B1, B2, C1, and C2. Then this became easy to integrate. But as you see, this is a very long and huge calculation that we are dealing with. So to avoid this universal and sure method that gives the integral, we can use some different change of variable to have. So here I didn't finish the calculation. It can take 13 minutes to finish this calculation and the integral below. But this is the first sure and long huge calculation. Let us move to the second way or method. The second method here consists we have 1 minus sine x. So here we can write like this: cosine x times 1 minus 1 plus sine x over 1 minus sine x dx. Plus minus 1, we didn't anything. No change. And this is equal to cosine x times 1 plus sine x minus 1 cosine x over 1 minus sine x dx. No change. This is equal to cosine x over 1 minus sine x dx minus the integral cosine x dx. Why? Because here we take minus 1, so we get minus 1 minus sine x, and we can simplify this. This gives us, the first one is d sine x over 1 minus sine x. The derivative of sine is cosine, so this is the first one, minus the integral of cosine is sine x here. But this is exactly minus ln absolute value of 1 minus x minus sine x plus constant. So you can understand that the universal method can take many efforts and huge calculations. So this is the second method. Third method. So can we propose a third method? Yes. Let 1 minus sine x be equal to new variable t. This implies that minus cosine x dx is equal to dt, which implies that dx is equal to minus dt over cosine x. And sine x is equal to 1 minus t. Then this integral, let us call it e. So this integral e takes the form cosine stay. Sine x is 1 minus t over 1 minus sine x is t, and the dx is times minus dt over cosine x. So we can simplify and we get minus the integral of what? 1 over t, so 1 over t dt minus, so we have here minus with minus, so plus, So plus the integral of dt. Here we have minus with minus. We take minus 1 over t plus t. Yeah, this is. For the first, this is minus ln absolute value of t. And from the second is plus t plus constant. Let us move to the original variable, which is t equal to 1 minus x. So we get here in this line is equal to minus ln absolute value, so 1 minus sine x plus t. T is 1 minus sine x plus constant, so we can write just minus sine x plus constant. The 1 will be in the constant c, since it is a constant. So this is the third way. The fourth way. So here the first way and the second way and the third way gives us the same primitive, the same form of the primitive. A third way, the fourth way, sorry, this is equal to cosine x sine x over 1 minus sine x times 1 plus sine x over 1 plus sine x dx. And we can find that this gives us cosine x sine x plus cosine x sine x square over 1 minus sine x square dx, but 1 minus sine x square is equal to cosine x square. So this takes the form sine x over cosine x. So for this we simplify cosine with 2, so we get sine x dx. And here we have cosine x over, so here we have plus the integral of sine x square over cosine x dx. Yeah, you can check it. For the first one, for this one, we have ln, so this can be written as below. So this is equal to d cosine x over cosine x with minus, because the derivative of cosine is minus sine, and we have here minus the first one dx plus sine square is 1 minus cosine square, so this is the integral of dx over cosine x minus the integral of cosine x dx, 1 minus cosine square dx. So for the first one, this is minus ln cosine x plus minus for the last one, so cosine, so minus sine x for the last one, plus it remained this one. This is the last one. So this we can times by cosine x over cosine x square dx. Just let us deal just with this one. So cosine over cosine square, this one, cosine x over cosine x square dx. There is many ways to solve one of cosine x. This can be written as d sine x over 1 minus sine x square. You understand the derivative of cosine is sine is cosine, and cosine x is equal to 1 minus sine x square. And this is equal to 1 over 2, the integral of 1 over 1 minus sine x plus 1 over 1 plus sine x dx. Let us check. Here we have 1 plus sine x, 1 minus sine x. We cancel minus sine with sine. We get 2 over 1 minus sine x square, 2 with 2, so it is exactly this one. But this last one allows us to replace this integral by what? By 1/2. This gives us the minus ln absolute value, and this gives us ln absolute value. So this is ln 1 plus sine x over 1 minus sine x plus a constant. You can here remark that we have not the same form of the primitive. So a function can accept more than a primitive. That is because we can have different function with the same derivative. This is the fourth. Do we have fifth? Yes, I think that. We can, for example, just a joke. We can take sine x equal to t, and we can find, using the same technique, the final result, the primitive. I think that this is all for today. Thank you for watching, and see you in good health, inshallah, next.